If f of x equal 1 plus x cubed, that quantity to the 80th power, what is the 210th derivative at 0? Well, we're obviously going to want to kind of look for patterns and see what we can do to generalize, because we're not going to multiply this out 80 times. So let's just start with a simpler one just to kind of observe some things about it. So let's just take this squared. So we're going to have 1 plus 2x cubed plus x to the 6th. All right, let's take some derivatives of this and see what's going on. So if we took this and we did the first derivative, this constant would disappear and we would have 6x squared. And actually, I think I'm going to write this out as 2 times 3 because we're looking at a pattern, x squared plus 6x to the 5th. So this is what it looked like with the first derivative. And when you do that first derivative, evaluated at 0, it's going to be 0. So let's take a second derivative. And so we'll do power out in front. So we have 2 times 3 times 2, and that's going to be x, plus 6 times 5, and that's going to be x to the 4th. If we evaluated that at 0, that's also going to be 0. Let's take a third derivative, and that is going to be 2 times 3 times 2, a constant, plus this one will be 6 times 5 times 4, x to the 3rd. Now if we evaluate that one at 0, the x term disappears, and the answer is that constant, the 2 times 3 times 2. So if we take a fourth derivative, that constant's going to disappear, and we're going to have 6 times 5 times 4 times 3 x to the 2nd. And at 0, that's going to be 0. We're going to do 2 more derivatives, and then we've kind of got our pattern here. So this is going to be in the next derivative x, and that's going to be 0 at 0. And when we do the 6th derivative, we are going to have 6 times 5 times 4 times 3 times 2, and I'll put times 1. That is a constant, and therefore the 6th derivative at 0 would be 6 factorial. So that's informative. If we look to see kind of when we had a derivative that wasn't 0, it was on all of these multiples of 3, and that was because of this to the 3rd here, because when you start writing this out, when we write out the 1 to the 80th, we're going to have 1, and we're going to have something here on an x to the 3rd, and we're going to have something here on an x to the 6th, and it's going to keep going until our last term is going to have something on the front, and it's going to be x to the 3 times 80, or 240. But all of the terms are going to be multiples of 3. So when we start taking derivatives of that, if it's not on a multiple of 3, like when we did the first, the second, the fourth, and the 5th, there's going to still be an x in there, and when we evaluate that at 0, it's going to be 0. So only these multiples of 3 will give us an answer that's not 0. So the first thing we're going to do when we go to look at this is we are going to say, well, we want the 210th derivative, and our power on x was 3. We're going to see if that goes in evenly. If it goes in evenly, then it's going to land on one of those that has a constant. If it doesn't go in evenly, then we already know the answer. It's 0, because it's one of those that you'll have x's in every term, and evaluate that at 0 is going to be 0. Well, this does go in evenly, and we get 70. So this means when we take 210 derivatives, the 70th term that we would have had in this expansion is going to be a constant. So that's going to help us to figure out an answer. All of the terms previous to the 70th term are going to be 0 because they disappeared. We took enough derivatives that they went to a constant and then they went to 0. So nothing in front of the 70th term when you've taken 210 derivatives is going to be there. And so all the front is going to disappear. Well, everything after the 70th term is going to have the 70th term. It's going to look something like how this did. The 70th, well, let's go up here to the one that had the constant, to the third one. the 70th term is going to have a constant. The next term is going to have an x cubed, and the one after that's going to have an x to the 6th, and so forth. So if we're evaluating at 0, all of the terms after are going to be 0 because they'll have x's in them. So now we realize that the 70th term, and it's going to come from, well, it was the 70th term in the original expansion if we had expanded this thing all out. But we're going to have done the derivative 210 times, so this is going to be 210 factorial as part of our constant. But the other part of our constant would be whatever the coefficient was to start with on that 70th term. Because when we multiply this all out, they're not all ones in front. This has a 2. And if you had done this and multiplied it out 3 times, you'd have coefficients of 1 and then 3 on the next term, 3 on the next term, and 1 on the next term, and so forth. So if we want to know what that constant is, it's going to be this 210 factorial that came from keep moving the power out in front, decreasing the power by 1. So the power out in front is 210 times. But also we need to multiply that by whatever the original coefficient was in front of it. And how we find that is we use the binomial theorem. Let me remind you what the binomial theorem says. The binomial theorem says if you have a plus b raised to the nth power, we can express that as a summation, k going from 0 to n. And we take this combination. The top here is the power, 80. The bottom is the term number you'd want the coefficient for. Actually, I was writing it in general, though. Let me put the numbers in a minute. This is always the power, and then this would be whatever k you're on, whatever term you're on. Then this would be a to the n minus k and b to the k. So if you wanted to know the kth term of some polynomial like this one, we want to know the 70th term, its coefficient, we can find it with this. Now in our particular case here, our a was 1, so this doesn't need to be here because that's 1. And then our b is x to the 3rd. And so that x to the 3rd will be multiplied by this k, whatever term we're on. Okay, so let's put this means, I'll put it over here to the left, the combinations. N is 80 because that's the power, and then we're going to put 70 because that's the term number that we want. And we're going to actually write out what that original 70th term was, and that way we'll know what the coefficient is, and then we know if we take 210 derivatives, if we multiply by 210 factorial, we'll have what that constant is when you take that 210th derivative. So let's do this one, and the way this works is it's always the top numbers factorial divided by the bottom numbers factorial, and then the difference between the two's factorial. So this is the coefficient on the 70th term. The 70th term would have had this huge coefficient on it, and it would have had then an x to the 3rd 70 times. That's what would be in our case 70. And so you can see that was the original term was an x to the 210. So taking 210 derivatives, we have a constant, and that constant will be the coefficient of the original coefficient of the term times 210 by taking the derivative 210 times. Now, if you had this and you took your whatever your derivative number was and you divided it by whatever your number was here then, and it didn't go in evenly, that one's easy. Your answer's 0 because it's one of these terms like 1 and 2 and 4 and 5 and so forth. Otherwise, we've got to give this answer. It's such a huge number that you wouldn't, there's not really a way to express it, and there's no reason to simplify it. You just go ahead and enter it like that.